Okay, so today we are going to discuss these topics, fundamental equation of reachability, repetitive components and firing invariants, T invariants, seeking T invariants, synchronized Petri nets, basic behaviors and concept, and then an illustrative example. So, at the end will be discussed. Okay, so just to recall the previous notations uh, of linear algebra that we used to represent a Petri net in a matrix form, which is called incidence matrix. Okay, and incidence matrix is calculated by first calculating the output incidence matrix and the input incidence matrices, right? So W, which is the incidence matrix, is equal to the output incidence matrix W plus minus the input incidence matrix W minus, right? And this is represented by this formal notation. Wij represents the weights of the matrix, right? Okay, so for this given example, you see there are 5 places in this Petri net, right, in 4 transitions. Let's try to calculate the incidence matrix of this Petri net, right? So, you know, this is the W minus, right? We discussed in the previous class how to calculate this, right? So we label all the columns with transitions, T1, T2, T3, T4. Why up to T4? Because we have 4 transitions in this Petri net. And rows are labeled with places labels, right? P1, P2, P3, P4, P5, since we have 5 places in this given Petri net, right? So you see that in this matrix, we have 4 columns and 5 rows, right? And now, in this input incidence matrix W minus, you see that since this is a very paired example, okay, paired Petri net example, so you see that all the arc weights are 1, okay, and now if a transition is fired, so one place will be one token can be deposited in a output place. When token can be removed from an output input place, and so on, right? So you see that the weights in this input incidence matrix all are ones or zeros, right? So 0 means that there's no effect of the firing of a transition in a particular place, right? So if you look at this W minus matrix, now after firing of T1, okay, what changes it can bring in the marking of this Petri net, right? So if we fire this T1, okay, you see that a token is removed, okay, from this input place T1, right? And you see that there is no other token, okay, no other tokens are removed from other places like P2, P3, P4, and P5, okay? So look at the example. If you fire T1, okay, in this case, there is no token in P1, but if assume that there is a token in P1 and we fire then P1, what will happen? This token will be removed from P1. Okay, one token will be removed since the arc weight is 1, right? It is a pure Petri net, okay, and all the arc weights are also 1. Okay. Similarly, if we fire T2, okay, what will happen? Okay, suppose there are tokens in the place P2, at least one token is required, right? Then this token will be removed from place P2, it will be deposited in P3, okay? So this means that firing up T2, actually firing up this T2 removes one token, okay, from place P2, okay, and there are 0 weights in the rest of the column, right? Why we have, so there's a question, why we have 1 here, right? in the fourth row and third column? Anyone?
Because when there is a token in P4, so firing of T3 will remove one token from their
Yeah,
place.
yeah. This is the right answer. Okay. So firing of T3 only removes one token from place P4. Look at this T3. Okay. So the firing of this T3 will remove only one token since the arc weight is 1 here. Okay. We are not now discussing the deposition of tokens in output places. So we are only dealing with the removal of tokens from input places, right? So similarly, this is very interesting case, right? In the column T4, okay, right? In the third row, we have 1, okay, arc weight 1, okay, and similarly in the last row, that is the fifth row, okay, we have also 1 here, okay. So why we have 2 1s here?
Because T4 will remove one token from P3 and
P3,
also from P5.
P5, yeah, this is the correct answer, okay, right. Now coming to the output incidence matrix W plus. Okay, again we label all the columns with transition labels and all the rows with place labels, right? Okay, and now in this case, right, the firing of the transition, a particular transition, suppose transition in the first column, okay, will actually add certain number of tokens in the corresponding places, right? So if we fire T1, okay, uh, 0 token will be deposited in place P1, okay, and 1 token will be deposited in place P2, okay, 0 token in place P3, and similarly 1 token in place P4, 0 token in place P5. And now look at the firing of T1, okay. So what is happening after firing? Okay, you see that 1 token will be deposited in place P2. Okay, 1
Oh,
token
yes.
will be deposited in place P4. Okay, and there is no other arc connected to the rest of the places. So that's it. Okay, so you see that in the entries. Okay, with remaining places like P1, okay, P5 and P3, there are 0 weights. Okay. So similarly, if we fire T2, okay, here is T2, only 1 token will be deposited in place
P3.
P3. That is why we have 1 here, okay. And if we fire T4, only 1 token will be deposited in place P1, since P1 is the output place, the only output place, right? And the arc weight is 1, so 1 token will be deposited here, right? Now, to calculate the incidence matrix W, okay, you see that W is equal to W plus, which is the output incidence matrix, minus W minus, which is the input incidence matrix. So just subtract this W minus from W plus. You see that 0 minus 1, okay, we have minus 1 here, right? And then 0 minus 0 0 0 minus 0 0
1
0,
minus 0.
okay,
1
1
minus 0.
minus 0, so we have
That's
1,
right.
right? So you will also add this plus sign here, right? And so on. So finally we get this output incidence matrix W, right? Okay. Now there's another interpretation of this output incidence matrix. You can directly compute the final W matrix, that is the incidence matrix, from the Petri net. Okay, you don't need to compute the input and output incidence matrices. You can directly compute the output incidence matrix, right? How? Now, again, you see that in the in the final incidence matrix W, we have columns which are again labeled with all the transition labels, and rows are labeled, okay, with all the places labels, right, in ascending order. So T1, T2, T3, T4, similarly P1, P2, P3, P4, P5. Now you have to look at the Petri net, and first consider this T1. Okay, this is, since this is the first column of the matrix. Now after firing up T1, okay, how many tokens are removed and how many tokens are deposited? Okay,
One token.
right? So you see that if we fire T1, okay, so only one token is removed from the place P1, right?
And
And
two token.
two tokens, okay, one tokens are actually
P2
deposited
and
in the places P2 and P3. You got the idea?
P4. P4.
P4, sorry, yeah. Okay, so here we have -1, which represents that one token is removed from place P1, and corresponding to P2, we have +1, right? So this means that one token is added, okay, or deposited in the place P2 after filing up T1. Corresponding to P3, we have 0 weight, and this represents that 0 token is actually no token is
Removed
deposited.
or
Okay, there is no
deposited.
effect of T1 and P3. Okay, P4, corresponding to P4, we have +1, and this means that after filing up T1, one token will be deposited in the place P4, and similarly, there will be no token. They represent that there will be no token either removed or deposited. Okay, so there is no change, okay, in the marking of place P5, right? You got the idea? So
Yes, sir.
now just ignore the input and the output incidence matrices, W minus W plus, and look at the graph of the Petri net, okay? This bipartite graph, and directly now try to directly compute this W incidence matrix, okay? And which is easy. Now just consider now the last column, that is T4, okay? And if we compute now this column, okay? So by firing up T4, what will happen? One token will be removed from P3 and P5, since
And
these
P5.
are the only two input places connected to T4. And this, after firing
One
up
token.
T4, what will happen? One token will be deposited in the place P1.
P1.
Okay, so you see that place P1 in the entry, corresponding entry, okay, or intersection of this P1 and T4. Okay, we have +1 weight. Okay, similarly 0 weight here. With P3 we have -1 weight. With P4 we have 0 weight. With P5, okay, right, in this P5 row we have -1, right? You got the idea? Is it clear? Any question?
No, sir.
Okay, so this is a new interpretation, okay, a new way to interpret the incidence matrix, or to calculate it, right? There are two things: the calculation of the incidence matrix from the Petri net, and the interpretation of the incidence matrix, right? Okay, so this is actually the explanation how this incidence matrix will be calculated. Okay, and now coming to the okay, just note here that if a Petri net is pure, okay, its incidence matrix enables the unmarked Petri net to be constructed. Okay, you can construct the incidence from the incidence matrix, the unmarked Petri net, right? Okay, so we don't need the given initial marking, okay, for the calculation of the incidence matrix. Okay, um, now in the case of impure Petri net, right? You know what is a pure Petri net? This is one of the properties, okay, of the Petri net, right? if the upper bound of the marking, okay, is 1, right, then the patronate is called pure, right? In other cases, it will be impure, okay? So if a patronate is impure, the unmarked patronate cannot be reconstructed from its incidence matrix. So we can only construct, okay, from the incidence matrix if the a patronate if it is pure. Okay. Now coming to the fundamental equation, okay, uh, you see that we discussed in the previous lecture the equation mk is equal to mi plus w dot s. Okay. Actually, mk is the marking reached, okay, from the initial marking or given marking mi, okay, if this s vector is fired, okay, this is a firing vector s, right? So we compute this s from the sequence of a firing, okay, sequence of transition which are to be fired, right? So you see that in the if we have suppose the initial marking, okay, which is suppose this M1, right, 0, 1, 0, 1, 0 in the previous example, this means that there is 0 token in the place P1, 1 token in the place P1, 0 token in the place P, uh,
P3,
sorry, this was in the P1, so P1
P1,
has 0,
P2,
P2 has 1, P3 has 0, and
P4, 1.
P4 has 1, P5 has 0. So only two places have token in them, right? That is P2 and P4, right? And now this W represents the patronate, that is the incidence matrix of the patronate. And now this S, actually this S1 represents the firing
Firing
vector,
sequence.
right? The firing sequence. And the firing sequence, only one transition will be fired, which is T2, right? So if you go back to the previous example, there are 4 transitions, and all right, 4 transitions. Look at this figure, okay, T1, T2, T T3, and T4, and we only fire, okay, T2. That is the firing sequence contains only T2, right? So now here we have tokens in place P2 and P4, right? So now in place P2 and P4 we have tokens. So if I file this T2, okay, what will be the new marking? Okay, firing up T2, okay, will remove this token from the input place and will deposit it in the P3 place, right? So the new marking
0,
will be 0,
0,
0,
0,
1,
1,
1,
1, 0.
0. So let's see what happens if we okay, compute uh, the reachable
M,
marking using this fundamental equation. Okay,
0,
so
0.
you see if after multiplication of these two matrices, okay, we get 0, minus 1, plus 1, 0, 0, which is a column matrix, right? And by adding this with the initial matrix, all right, initial marking, which is represented by this column matrix, right? So we get 0, 0, 1, 1, 0, right? So we see that after finally we get, okay, a marking, okay, right, which represents that there are 0 tokens in the place P1, 0 token, okay, in the place P2, and similarly 1 token in the place P2, P3, P4, and 0 in place P5, right? And this is the new marking which is reached, right? You got the idea?
Yes, sir. Sir, Chimang, next firing sequence da go the M2 boss for the general equation की work हो, for the fundamental
او
equation.
دې نه بعد که فرض که مزید تاسو بیا فایرینګ کوئ نو نو
M2 plus
بیا به
W
سره
dot
کرنٹ
S2.
مارکینګ یا انیشل مارکینګ M2 وي صحیح ده
Ah, sir.
اوکې So consider, okay, so it is also explained here, right? Now you see that we have P1 token and P2, one token and P4, right? Okay, and after firing up T2, what happens? Okay, we have one token in P3, one token in P4, and other places have 0 tokens, right? And suppose the firing sequence, this is the firing sequence in this case is T2.
T2.
But we can consider, okay, other firing sequences, right? Such as T3, T4, T1, T3, okay? And for this, what will be S vector? For this T3, T4, T1, and T3. What will be S
S
vector?
vector.
Yeah.
S vector will be
1,
1, 1, 1, 1, 1.
1, 0. There is no T2. So 1, 0. And then T3 is occurring 2 times, so 2. And
1,
then
0.
T4, so we have 1, right? So 1, 0, 2, and 1. Okay.
1,
And
0,
so this will be the S matrix,
S2.
right? And what about the S matrix corresponding to this sequence, firing sequence? So we have T1, you see. So we'll write 1, okay. We have T2, so we'll write 1, 1, okay. Then T3 is occurring 2 times, so 2, okay.
1,
And then
1,
T4 is there, right? So
2,
1.
1.
So actually,
1, 1,
yeah,
2, 1.
yeah. So you see that 1, 0, 2, 1. So 1, 0, 2, 1. Why? Because it is corresponding to this one. Okay, 1,
Yes, sir.
0, 2, 1,
1,
right?
0, 2, 1. Yes.
And what is the current marking or the initial marking? 0, 0,
M2.
1, 1.
0, 0, 1, 1, 0.
So you see here 0,
0.
0, 1, 1, 0. And then W is the same matrix.
Same
Multiply by
matrix.
this S. S is now
1, 0,
1,
2.
0, 2, 1. Okay. So after multiplication and then addition of these matrices, you will get 0, 1, 0, 0,
0,
1. So finally,
1.
we have one token in the place P1,
T2.
one token in the place P2, 0 token in the place P3, 0 token in the
P3.
place P4, 1 token in the place P5, right? So this is actually the marking. M3 is the marking reached, okay, after filing up S2, right? From the current marking 0, 0, 1, 1, 0, right?
M2.
Any questions so far?
اثر کدا موږ د سیکوینسز په اخر کې بیرته زموږ سره M1 نه موږ سٹارټ اغسته واپس M1 ته راورسېدو نو اټ مین چې دا به ریپیټیټیو دغه
Reversible.
به
The
ریورس
Petri net will be reversible, okay? Since the Petri net reinitializes itself, okay? It actually reaches to the initial state, okay? So this means that it is a reinitializable, okay? Or it's a reversible patch of it. You got the idea?
یس
Okay. Is there any button for stopping the recording for a while, or there's no? Okay. Okay. So the assignment is, right? This is a class assignment. Just consider that the initial marking is 1, 0, 0, 0, 0. Okay. And this contains 1, 1, 1, 1, right? And then compute the MK, that is the marking reached after firing up this S vector. Okay. Is this assignment clear?
یس سر
Okay. So you have 2 minutes, right, to solve this problem.